Uh, yeah, few before moving on to the next session, few guidelines. For all the speakers, make sure your connection, your network, your audio are in good shape and place. Uh, and if it is possible, during the session, do check out the Zoom chat. If we want to send any information about the session, we would be posting it over there. Okay. Moving on, moving on to our next speaker, Sagar Jadhav. He has over 6 years of experience in software development. He has experience in wide range of tools and technologies such as Java, Node.js, JavaScript, Cloud, Docker, Kubernetes, Go, and Terraform. He's currently backend developer at IBM. He's working in hybrid cloud space and is involved in products that are responsible for multi-cloud deployment and management. He's always keen to learn new technologies, especially related to DevOps and cloud native. And he also believes in sharing the same knowledge with others through meetup, conference, webinars, and blogs. He's actively involved in speaking and volunteering in different technical meetups and events in Pune. Over to you, Sagar.
Yeah, thank you, Chinmay, and thank you, OSCONF, for giving me this opportunity. Okay, so let's get started. Hey, hi everyone. So today I'll be speaking on topic which is Orchestrate Application deployment using Helm and Terraform. So this is who am I, right? And thanks Chinmay for the beautiful information. So I'll be speaking this piece because it's already been spoken by Chinmay. So let's get started. So the agenda of today's talk is I'll be going to introduce a use case. So we'll be solving a use case, and that use case will be solving using two well-known technologies in DevOps, which is Terraform and Helm. So the first piece is we'll introduce to the use case. Second thing is we'll see how to solve this use case using a legacy approach, right? So we'll see like what is the legacy approach that we can use to solve this approach. And then we'll also see like what are the disadvantages we have with this approach. And at the end, we'll discuss how to solve this use case optimally using the Terraform and the Helm. So this is all agenda I have, and it's going to be a demonstration along with the mix of slides, right? So the prerequisites for this hands-on demo, right? We should have a Kubernetes cluster in place. We should have Helm CLI installed on your workstation. Then Terraform 12. I'm going to use the latest version of Terraform. And then we'll require Python 3 as well as account on the mail trap, right? So Python 3 and mail trap I required because it's part of my flow wherein I wanted to send the email once the application is deployed successfully, right? So this is it. So this is about the introduction to use case, right? So let's say I have an application and it's a microservices based application wherein I have two components. So the one component is front end, other component is back end, right? Now my use case is while deploying this application, my front end depends on the back end. And what I wanted to achieve once the application deployed successfully, I want to send an email to the administrator, right? Now, why there is a dependency? Let's say we have a backend application, which can be a database. So we wanted to inject the URLs of those database along with the port information, the username and password in the front end application so that it can talk to that backend, right? So we have this dependency in place. Now, this is the basic use case, but then you can make use of this use case and enhance it for your real-time applications, right? So let me reiterate the use case. We have an application which comprises of two components, front end and back end. My front end depends on back end. And once the application deployed successfully, I wanted to send an email to the administrator. So this is all about the use case. We are going to solve this use case with two approaches. The first approach will be a legacy approach, and second approach will be a new approach using the Helm and the Terraform. Now, how we are going to solve this using a legacy approach? So we'll be using the concepts of Helm dependencies. As this application is a cloud native application, a microservices based application which comprises of different Docker components, Docker containers, sorry. So we'll be using Helm to deploy that application. To maintain the dependency, there is a concept in Helm which is like Helm dependency, wherein we can have a dependency like parent and child. So we'll try to see like what that dependency is. Second, we'll require an email script to orchestrate the complete flow. Okay. And third, we require a script which will actually send an email, right? So this is how we can solve this particular use case, right? So let's get started. So the first point is like, how about the Helm dependencies, right? So this is the picture of a Helm chart, which comprises of two charts, right? So the first chart, which is the front end underscore dapps, it's the parent chart, right? And the chart which is under the folder, which is chart section, which is backend underscore devs, is the child chart, right? So basically we have created a parent-child relationship between the front end and the backend, right? So here the front end dependent on backend, right? So what we want a backend application to be deployed first, and then we want a front end application to be deployed later, right? So that is the reason we have used the Helm dependency concept, right? And we have created the charts in this manner, right? So any chart for which the front end has dependency, you have to put into this charts folder, right? So now the next thing is the email script, right? So this is not a rocket science kind of thing, right? But it's a simple Python script that I have written, and basically what it does, it will just take some parameters and then it will send an email to the administrator that my application is deployed successfully, right? And the third thing is very simple thing, right? So what we have a shell script which has two statements. The first statement will be installing my application, and the second statement will be executing my mail script, right? So this is all I'm doing.
Sagar, can you share your screen?
Yeah, I'm sharing my screen, Ajeet. Just a minute.
Okay, you can go ahead.
Yeah. So sorry, like it's in a rush. Like I forgot to share my screen. So let me just reiterate my slides again so that you have a better understanding, right? What I'm trying to explain. So we have this we have this agenda in place, right? I already spoke about it, right? Second, we have this prerequisites. Like we wanted this prerequisites to be installed on your workstation. Next, we talked about this use case, right? So I have like created a diagram wherein we have one application with two components and the application deployment flow, right? Second, we have used this legacy approach. This is all about the pointers that how we are going to solve, right? And then we have this diagram which states like how the chart looks like. So we have a front end chart which is our dependency on backend chart, right? And then we have an email script. So this email script is nothing a simple Python script which actually send an email to the administrator saying that application deployed successfully, right? And we have a shell script which actually install the Helm chart along with the sending an email to the administrator. Now let's go ahead and let's do the demonstration, right? I don't want to like share the slides again and again. I just go ahead to my terminal. So let's access my terminal here. So this is my terminal, right? Before that, let me jump into the VS Code and show you the code snippet that I have, right? So this is the directory we have, and we have different charts listed here. So this is the script I'm talking about. So the first piece will be going to initialize my connection details. Second, we are going to install the application via the Helm install command. And third, we are going to send an email via Python script, right? So although it's a very simple use case, but then you can enhance it for the much complex use cases, right? So let me switch back to my terminal. Let's do one thing. Let's initialize some of the connection parameters. Okay, and then let's jump into the terminal and then execute the script. So this script is responsible for executing the commands that I've shown earlier, right? So what it will do, it will initialize the connection detail. It will install an application on Kubernetes. So basically it will run the Helm install command. Now once the Helm install command runs successfully, it sends an email to the administrator, right? So let's check like whether the release is created in Helm or not, right? So I have just executed a command which is Helm ls, which will show me like whether there is any release created or not. So we have a release which is dependent apps, right? So let me also see like what all the resources that it has created. So let me do kubectl get all -n demo, right? So basically all my resources is created in namespace demo. So let me show you the resources that it created. So it created a pod. We have, as I've told earlier, we have an application which comprises of backend and front end, right? So here DB is a backend, PHP admin is a front end. Now we wanted this application to be exposed to the external world. So that is the reason I have created a service with of type notepod, and then we have a deployment with the replica set. Now let's go ahead and let's browse our application. So before that, let us also verify whether we have a mail received or not. So yes, we have received an email, which is also saying me like this is the password for the root user. Let me go to the let me go to my browser. Let's refresh. So basically, I have created a Kubernetes cluster on the IBM Cloud account, and we have this worker node running. So it's a single node cluster, right? And it has this worker node has an IP address this, and this is the port where I have hosted my application, right? So let me log in with my root user and the password test. So yes, I'm able to successfully log in my application, right? So this is all about like how you can deploy your application using the Helm dependencies, right? So let me switch back to the presentation and let's see like what all the disadvantages we have with this legacy approach, right? So basically the first and the major problem is like the solution is made out of a shell script, right? So it's not a long-term solution. Maybe there could be use cases that eventually you have to put into your like shell script, right? And then it will eventually become more complex, right? So I'm talking about the use cases wherein you wanted to do the error handling. Let's suppose you install the chart. Let's suppose something went wrong. Now you wanted to shoot an email. Okay, then let's suppose you want to pass in the arguments, right? Let's suppose there is a rollback strategy, right? Wherein you are doing something and then you wanted to roll back. Right? How you will do it, right? So that is the reason it's not recommended approach, because the shell script will become more complex and we don't have any standards wherein we can maintain the like the syntax and the grammar of your code, right? Second thing, and the another important here, we have written the script to send an email, right? But what if instead of email, I wanted to send a push notification or SMS or anything else, right? So this code is not modular, right? So it's not a modular approach to do things, right? So basically that is the reason we have come up with the approach which comprises of tools, which is Terraform and Helm. So basically, Terraform and Helm both are the tools which is basically following the strategy which is known as infrastructure as a code. So basically, you codify your infrastructure, right? So there is a different language. So Helm has its own language. Terraform has its own language, right? So we return the complete infrastructure and we codifies it, right? And then we deploy it, right? So how we are using? So we are using Terraform as an orchestration engine. When we say an orchestration engine, that means, as you can see in my flow, let me go back to this slide again. As you can see in my flow, I have three different tasks. So the first task is to deploy a backend. Second is to deploy a front end, and the last task is to send an email, right? So we have three tasks in my flow. So here I'm leveraging Terraform as an orchestrator engine, right? We'll see the code, how I written that code. Second, we'll install Helm Terraform provider to install the application, right? So here you will see I'm not executing the Helm CLI command. I will be using the Helm Terraform provider, okay, which itself supports deploying an application to the cloud, right? And third, and the important thing, there is a module in Terraform which is the local exec, which is used to execute the shell script. Okay, so now let's not waste time in understanding this. Let us see. So it's a brief image which shows like how my Terraform looks like, right? But then I will switch back to my Visual Studio Code and let me show you the complete piece of code, like what I have written, and then how you can enhance it to as per your needs, right? So this is my Terraform file, right? So the file name is main.tf. So as you can see at the top, I have mentioned the provider. So basically, throughout this Terraform file, I'll be using that Helm Terraform provider. So this is the constraint. We have to specify that which version of provider you are going to use in your application. Second thing is I have used this module which is used to generate a random password, right? So this is also one of the things that I've did in my flow. wherein every time I deployed my application, a random password is generated for my backend, and that password is propagated back to the administrator via an email, right? So that is the reason I have used this module. So you will see that I have not written any script for that. I have just used a module, which the name of the module is random password, and the resource name is password, right? And here the magic is, right? Here the magic happens with this statement. So this statement defines whether this model depends on which resource, right? So as we are maintaining a dependency, right? So if you see, this is my front-end application, and you will see it depends on two things. It depends on backend. It depends on this resource. So what does it mean? It means that before installing this resource, Terraform will install this resource as well as this resource. So we will achieve whatever we wanted, right? So that is what we wanted to achieve. We wanted that a backend to be deployed first, and then later on we'll install the front end, right? So, and if you go to backend, so here we have one dependency. We are dependent on this resource because we are leveraging the value generated by this model in this release as well as in this release. And how we are injecting the value? So basically, so if you have worked in Helm before, there is a concept of like values.yaml wherein you can inject the values in different forms, right? So I'm setting the value of MySQL password, and the value is coming from this model, right? And at the end, the other thing, wherein let's suppose there is a unique use case wherein you don't want to create a resource, but then you want to execute a shell script or a Python script. So how you will do it in Terraform? So for that, Terraform introduces a resource which is known as null resource. The name is very good, right? It itself says that it will do nothing. But then there is a model there is a provision which is local exec. So what it does, basically it executes the script on your local workstation where the Terraform is running, right? So basically what I wanted to send an email using my Python script, right? So, but in my disadvantages, I've mentioned that the script is not model, right? So here, what we can do, if we wanted to enhance it more, what we can do here, we can replace this with a AWS resource, a push notification resource, which will send a notification to my SNS queue, and that SNS queue has a receiver, which is an email, right? So in that way, you can enhance this flow, right? So this is what I wanted to show. The next thing will be a variables.tf. So basically, it's a good way to modularize your Terraform files, wherein you can modularize, where you can inject put the variables in the variables.tf, right? And the last thing that I want to show you is one thing. So this is my Helm chart. So I've talked about a variable which is MySQL root password. So if you see, this is the Helm chart values.yaml file, and wherein I'm mentioning that this is the value which is you have to inject in the deployment, and then how we are injecting through this syntax. So if you see, I have used, so here Helm is also codifying my container-based app infrastructure, and my Terraform also codifies my like complete infrastructure, right? So now let's move to the terminal and let's do some magic here, right? So basically I have created this resource. So let me remove this, right? So to remove the previously installed resource, there is a command in Helm which is Helm uninstall. You can also use Helm remove and Helm delete as well. So what it does, it just required a name of the release. So I have provided the name of the release, and then what it does, it will remove all the resources, right? So let us also verify. So let me just do a get on the resources. So get all on the demo will list all the resources which is present inside my namespace. So basically for this demonstration purpose, I have created a namespace, which is the name is the demo piece. Okay, so now here the main thing, right? So to execute the Terraform, you can do various steps. So the one command would be like Terraform init. So basically when you execute the Terraform init, it will initialize all the provider and stored in a folder, which is, there is a folder which is, there's a dot Terraform directory, right, where it contains, right? So let me do one thing. Let me remove the files which is not required right now. So let's run a single command, Terraform apply. Let's run it. So when we run this command, it will first show me the plan. So the plan is, it will show you like what all resources it will create, right? So if you see the count here is, it will create 4 resources. Why 4? The one resource. So Terraform is also considering this as a resource because it is done, although it's not creating anything infrastructure wise, right? But then also it is generating a password for us. So this is one resource. This is a resource which does nothing, but then we can execute the script. And now these are the two resources, which is the resource which is corresponding to my Helm chart. One is my front end and the other one is the back end one, right? So if you see like particularly the arguments which is getting passed to my Helm chart, right? So this all arguments supports via the Helm install command as well, right? So that is the reason, like, it's very easy to use this, right? Now what is asking? It is asking my approval whether I wanted to deploy this infrastructure or not. So let's deploy it, right? So when I click on yes, just observe one thing, that it will execute all those things sequentially. First it will install the random password resource, okay, because it's the resource which other resource dependent on this resource. And then as per our flow, we want our backend to be deployed first, right? So then it is installing the backend char. So, and this another thing, right? It will not like fire and forget kind of thing. It will install the chart and wait until all the pods and resources go into the running state. So this is a very important thing, right? Because this is the whole idea about our use case. We want our backend to be deployed first, and then we want it to go for a front end, right? So it installs my backend chart. Now it is installing my front end chart. So once it completed installing my front end, then it will go ahead and install the last piece of thing, which is the local exec, right? After this demonstration, I will also show you, like, when we remove that depends on, what will happen, right? So it says apply complete, all the resources has been added. Let us verify. So let me do Helm ls. So if you remember the previous Helm ls command that I've used for legacy approach, it shows only one release, right? But now it is showing me two releases because I have this releases deployed separately, right? So here I have all the releases deployed. Let me also verify whether the resources on Kubernetes is also get deployed or not. Okay. So let me do a get all on my namespace demo. So we have all the resources which previously deployed. Now here the another magic that I'm going to show you is that here the mail is shoot, and if you see the password is not test. So it's a random. So every time I fire this, it will generate a random password. So for security reasons also, this is a good practice wherein you don't need to rely on any script. You can just use the random password resource module, and then you are good to go with the generating the random password. So let me paste this command. Let me just do a login. And if you see, I'm able to log in my application, which I have deployed using Terraform, right? Now, previously, I have used the helm uninstall command. Now, to destroy the resources here, there is a command which is very simple, and here you don't need to give the release name as well. So it's just Terraform destroy, and just observe the sequence where how it destroys the resources. So it's the reverse order. Previously, it started with the null resource. Now, if you see it, the order will be reversed. So it will start with my the null resource, and then it goes to the front end, then the back end, and the random, right? So basically, when Terraform does the apply, it generally creates an acyclic graph, and it creates a dependency out of it, right? So basically, and this is the thing, right? We wanted the dependent one, the chart which is not deployed, which is not dependent on anything to be deployed, to be deleted first, and the later on, right? So it again goes back in the reverse order. It destroyed all the resources. So you will see I don't need to run helm uninstall command. So within a single command, and one more thing, right? Here I'm just installing my application. But let's say if you wanted to do some cleanup as well, you can also do it by a single command. So let's just verify. Let me do helm ls again. You will see there is no resources present. Now the last thing I wanted to show here is this thing wherein, let's say we'll remove this depends on, and we'll see like what happens. So because depends on is the key here. So let me remove this. Let me remove the depends on from here as well. And from here as well. So I've removed the depends on. Okay. Now let's go back to terminal again. Let me run the Terraform apply. Let's run this. It will do the plan again. Let me click on yes. You will see the difference, right? It as Terraform didn't find that there is a dependency between the different resources. Basically, it executed all the resources parallelly, right? So although it is good for your infrastructure wherein you wanted to speed up your deployment, right? So you can deploy the infrastructure parallelly. But then in our use case, it doesn't make any sense, right? We wanted there is a dependency, right? So you will see that it does this thing. Now, why it says namespace is demo not found? Because there is a mismatch, because this demo YAML file is present in the backend, right? But as the front end fires up first, it doesn't find the demo namespace and then it throws an error. So we'll see that it's throwing an error for front end, right? So that is the reason I've used depends on, and you can use it for your application as well to deploy the infrastructure piece, right? So I think I'm good with times as well. And I've done the Terraform apply. And then the last piece, you can get in touch with me via Gmail, via LinkedIn, Twitter, and GitHub as well. So I've also put this piece of code in the github.com. So after this conference end, I will going to share all this code with you. You can get connected with me, and then we can discuss like how to make this use case more complex, right? The reason I've took a very basic use case because we wanted to understand the bits and pieces of different technologies, right? It's always good to have a hello world with any new technologies. So that is the reason I used this use case, but then we can enhance it to have more, add more complexity to it, and then we can do it later on as well, right? So this is what all I wanted to share. I think Chinmay, I'm hand over to you. So just tell me if I have any questions for me, I can answer that.
Yeah, Sagar. There is one question from Prathamesh Kulkarni. He's asking about is this code available on any public GitHub repo?
Yes. So Prathamesh, that is that is one thing that I've did. I've already have a GitHub repository. So once that conference is over, I'll be going to put a step-by-step documentation, a README, and then I'm going to send across via the so OSCONF will send across an email maybe wherein you can get all those details. Okay, or else I will just put a comment on this video and you will get it. So content is already there on GitHub. Any more questions, Chinmay?
No, that's it, Sagar.
Yeah. So thank you guys and have a good day. Stay home, stay safe. Once again, thank you OSCON for giving me an opportunity to speak on the topic which I love to speak, right? Thank you. And let me just stop sharing.
Yeah, thanks, Sagar. For all the join-ins, do check out the description in YouTube live session. It has the entire agenda and links to all the meetup groups and the learning materials. If you want to connect with the speakers post-event, their LinkedIn links are available on our Collabnix site, so you can check out over there. So let's.
Can you please disable my screen share? I am not getting the control.
Okay, I think moderator. Apurva, can you do it?
Bhavin can do it. Okay.
Bhavin need to change. Yeah.
Sangam, sorry. Sangam, can you start the game? Yeah, sorry.
Yeah, so we are now into the next quiz game. So again, you need to go into the Kahoot.it. We already know how it works as we have already played it earlier. Or you can use the Kahoot app. The game pin would be 540793. So as I've seen a few queries on the YouTube chat, it says the options are popped before the question has been seen, but it's all because of the lag that we see in the screen sharing. So nothing much we can do about this technical challenge. But again, it would I believe it will be just a second of difference, and that shouldn't be an issue. And since it would be same for all, I think it's fair enough. So let's wait for more people to join. So Sangam, can you just refresh? I don't see people joining over there.